Oink, oink. Oh, hi everybody. Welcome back again. Woohoo! Oh, hi Lop. Hi Byron. I'm Stretchy. And I am Morgan. Ah! Ouch! Sorry, brother. It's okay, brother. Today, we're going to be learning about fractions and decimals and how to compare, add, and subtract them. Comparing unit fractions and decimals. Excuse me, I have the sniffles. The bar at the top represents a whole watermelon. Below are unit fractions and unit decimals made by dividing the watermelon into equal parts. Suppose there was a watermelon, and this represents the whole watermelon. Well, you see, this represents half of the watermelon, because that is basically 1 divided by 2. That's half of 1. Half is half of 1, obviously. And if we divide 1/2 by half, we get 1/4. And if we divide that in half, we get 1/8. Yes! We could just keep dividing fractions in half. Yes. But did you know that you could compare such numbers? It's very simple. 1 is at the top because it is simple, it's easy. It's represented by 1 divided by itself. 1 divided by 1 is 1. Same thing as 1 times 1 is 1. 1 is basically the whole watermelon, so it's 1 over 1. The whole watermelon here, which is 1 divided by 2, reads as 2 divided by 2. Any number divided by itself equals 1. So, 5/5, for example, equals 1. 7/7 equals 1. 9/9 equals 1. So, how to compare them? The easiest way to compare unit fractions is to think of it like measuring the blocks. Yes! Since 5 is greater than 3, you might think that 1/5 is greater, right? But you are wrong. 1/5 is actually less than 1/3 because the 1/5 block is shorter than the 1/3 block. Yes! Plus, if we divide them both, 1 divided by 5 is 0.2, and 1 divided by 3 is 0.3 repeating. And 0.3 repeating is greater than 0.2. So, that's how you could also remember it. 1/6 is also less than 1/4, because 1/6 blocks are shorter than 1/4 blocks. This is very amazing. This is how you could compare fractions and apply them to daily life. Yes! There are tenths and eighths and fifths and thirds and halves and a whole, which you can use. Yes! You could also compare decimals, like 0.1. Well, 1/10 is 0.1. 1/10 and 0.1 are the same exact thing, because 1 divided by 10 is 0.1, which translates to literally 1/10. Yes! So, 1/10 and 0.1 are equal or the same. So 1/10 equals 0.1. That's when they're equal. That's when the 1/10 block is as long as the 0.1 block. So if 2 of these things are equal, then one block must have the same length as the other block. That's how it's equal. And there is even something about dividing it into hundreds. Wow, hundredths over here. Yes, this tiny rectangle, over here shown by this black arrow is 1/100th. And that is just 1/10 of 1/10, because 10 times 10 is 100. Yes! So this is 100th, 200ths, and then it keeps going on until we reach 100 hundredths, which makes the whole watermelon. Cool! The greater the dividing number is, the smaller the unit fraction or decimal will be. The fraction denominator and the decimal place show the dividing number. So a greater denominator or decimal place means the whole is divided into smaller parts. Because, as we talked about earlier, 1/4 is less than 1/3. Or wait, I said 1/5 is less than 1/3, not 1/4. 1/4 is less than 1/3, but I said 1/5 is less than 1/3. They are both less than 1/3. So, anyways, yeah. Because they both exhibit a shorter distance than the 1/3 block does. So, it matters with distance. So, let's go over here. 4 is greater than 3, but 1/4 is less than 1/3. And why is that true? Well, it's very simple. It's because the 1/4 block is shorter than the 1/3 block. Yes, if you think about it, 1 divided by 4 is 0.25, and 1 divided by 3 is 0.3 repeating. 0.3 repeating is definitely greater than 0.25, because 3 is the greater tenths place. So 1/3 is greater, and 1/4 is less. Over here, it's the same thing, except with decimals. 100 is greater than 10, but 0.01 is less than 0.1, because 0.01 is only 1/100th or 1/10th of a tenth, but 0.1 is 1/10 or 1/whole of 1/10. So 1/100th is less than 1/10. It's basically 1/10 of 1/10. Very cool. And finally, the last one. 1,000 is greater than 100, but 0.001 is less than 0.01. Because, in this case, 0.001 would be 1,000th or 1/10th of 100th. However, 0.01 is equivalent to 100th. So 1,000th is less than 100th. Wow, that's very nice. Ranging from tiny to large. That's very cool. Yes, it is very cool. We could compare fractions and decimals. Now, I think you already know what a decimal and a fraction are, but I'll just tell you again. A fraction is a number that has the numerator and denominator that represents these. The numerator tells how many of these unit fractions the fraction represents, and the denominator of a fraction tells the number of equal parts the whole is divided into, and therefore, the number of unit fractions that are made. And by the way, a unit fraction is a fraction with a numerator of 1. So, yes. Numerators and denominators are represented by the letters N and D. N for numerator, D for denominator. N for how many of the unit fractions the fraction represents, and the denominator for the total number of equal parts the whole is divided into, and the number of unit fractions that are made, therefore. So, if you look at this picture, okay, yeah, looking. Wow, look at this giant ring. 1/7 plus 1/7 plus 1/7. That must equal 3/7, right? Yes, because this is as long as the loop, so that's 3/7. What about here, though? 1/7 plus 1/7. Ooh, I think that's 2/7. That's right, because 5/7 is 2/7 greater than 3/7. So that's 2/7. 3/7 plus 2/7 is 5/7. The loops stop here. So the answer to the addition problem is 5/7, or 5 of the 1/7. 5 times 1/7. Well, 5 times 1 is 5. Don't multiply anything by the denominator in this case. Only multiply the 5 times 1 in this case. That'll be 5/7. Same thing here. 0.1 plus 0.1 plus 0.1 is 0.3. Plus 0.1 is 0.4. Plus 0.1 is 0.5. Yes, 5/10. Or again, 5 times 0.1. Don't multiply 5 by 0. You only multiply 5 by this to get the answer. Now what we're going to do is add, subtract, and compare fractions and decimals of the same units, which is pretty easy because the denominators and the decimal places are all the same. Now we need to add the fractions below. 3/9 plus 2/9. How do we get the answer? Well, let's think of it this way. Let's go back to the watermelon scenario, where the whole watermelon is 9/9. Imagine you split the watermelon into 3/9, but then you also split the watermelon in 2/9. How much of the watermelon did you split altogether? 3/9 plus 2/9 is 5/9. Think of it in kindergarten. What is 3 plus 2? 5. Do not add the denominators. That is a common mistake. You should add the numerators, but you should not add the denominators. Like, you should add the 3 and the 2, but you should not add the 9s together, because 9 plus 9 is 18, and 5/18 is less than 5/9. So, yeah. Plus, we have proof over here. Same thing for here. If the denominator is 6, then 3/6 plus 2/6 is 5/6. Yes, we could also add decimals with the same unit, where the hundredths, they are both hundredths. 0.03 plus 0.02. Again, what's 3 plus 2? 5. And how many zeros are there each? 2 zeros. With a decimal point. 0.05. Yes, we're starting to get the hang of this now. We could also subtract fractions and decimals with the same units as well. Like in kindergarten, what is 5 minus 3? It's 2. And what's the denominator? 7. Don't subtract the sevenths, because you cannot divide by 0, because 7 minus 7 is 0, and you cannot divide by 0. So 2 over 0 wouldn't make sense. 5 minus 2 is 3. Leave the 7 alone. That's 3/7. Same thing for over here. 5 minus 3 is 2. Leave the 9s alone. That's 2/9. Same thing over here. 5 minus 2 is 3. Leave the 6 alone. And voila, you get 3/6. Wow, you're learning this so quickly. Yeah, it's pretty much very simple. And now you could also subtract decimals when the numbers are both in the 10th place, like 5 and 3. 0.5 minus 0.3 equals 0.2, because remember, there is 1 0 in each number plus a decimal point, and 5 minus 3 is 2. So we could substitute the 0, the decimal point, and the answer to 5 minus 3 to get the answer. 0.5 minus 0.3 is 0.2. Same thing here. 5 minus 2 is 3, and there's a 0 plus a decimal point in each number. 0.3 equals 0.5 minus 0.2. 0.05 minus 0.03, quite similar, huh? There are 2 zeros and a decimal point. Let's substitute those. Then 5 minus 3, it's 2. So 0.05 minus 0.03 is 0.02. Excuse me. This means that 0.05 minus 0.02 is 0.03. Because there are 2 zeros, a decimal point, substitute those, and then 5 minus 2 is 3. 0.03 equals 0.05 minus 0.02. To add or subtract fractions with the same denominators or like denominators, add or subtract the numerators. To add or subtract decimals with like places or the same places, add or subtract the numbers in the places. Yes! But what about mixed numbers? What's a mixed number? Good question. A mixed number is a number that contains a whole number and a fraction, like 2 and 2/5, for example, like 2.4. Yes! So, yep, we could do the same thing with mixed numbers. But this is pretty different because it shows you steps. 1 and 3/5 plus 2 and 2/5. Well, think of it. What is 1 plus 3/5? 1 and 3/5, of course, because they're squashed together. Plus, 3 divided by 5 is 0.6. What's 1 plus 0.6? It's 1.6. So, yep, 1 and 3/5 plus 2 and 2/5 equals 1 plus 2, that's 3, plus 3/5 plus 2/5. That makes 3 plus 5/5, and 5/5 is 1, which is 3 plus 1, which equals 4. So the answer is 4. Yes! So, yep. Subtracting mixed numbers is a process used, and it requires ungrouping a 1 only if needed. Then, it requires to subtract the whole numbers and the fractions. 2 and 2/5 minus 1 and 3/5, because 2 minus 3 is a negative number. So, we have to ungroup a 1 if we need to, and that is when we need to use it. So, suppose 3 people, Susie, Ayan, and Young Shim, try to solve the problem. Who would solve it correctly? Let's see. So, Susie's method is pretty simple. 2 and 2/5 is 1 plus 5/5, which is really 1 plus 1, which is 2. Then, she did 2 plus 2/5, which is 2 and 2/5. But then, she explained how she got that by subtracting that from 1 and 3/5 for her to practice. 2 plus 2/5, 2/5 plus 2/5 is 4/5. 3/5 to 5/5 is 2/5, plus 2/5 equals 4/5. I count from 3/5 to 5/5, that's 2/5. I add 2/5 and another 2/5, that's 4/5. So, she thinks that 2 and 2/5 minus 1 and 3/5 is 4/5. Let's see if she's right. 1 and 3/5 plus 4/5. 1 and 3/5 plus 2/5 is 1 and 5/5, which is 2. Then another 2/5 makes, let's see. Well, we know that 2/5 plus 2/5 is 4/5. But if we subtract 1, that gets 1. And if we subtract 3/5, that is... So, if we subtract 1 and 2/5 by 2/5, then we get 1 and 0/5, which leaves 1. Then, another is 3/5, which makes 4/5. Susie's right. Let's check out Ayan's method. Ooh! Ayan made this mixed number into an improper fraction. An improper fraction has a numerator that is greater than the denominator. Then, he subtracted it by 1 and 3/5, and we get 4/5. And that is true, because 7 minus 3 is 4, and we do not subtract the 5. Young Shim's method uses an expanded addition plus a subtraction problem to solve it. 2 plus 2/5 equals 1 plus 7/5. Yes, that is true. Minus 1 plus 3/5 equals 1 plus 3/5. That is also true. That leaves off with 0 plus 4/5, because 7/5 minus 3/5 is 4/5. And if we cancel all these out, that leaves with 0. And 0 plus 4/5 is obviously 4/5. So, who did the problem right? Well, I think all of them got it right? Correct. Susie, Ayan, and Young Shim all got it right. They just solved the problem using different methods. All right. That is it for us today. I hope you enjoyed this video about fractions, decimals, and mixed numbers, and how different methods could work the same way in order to add, subtract, and compare such mathematical symbols. Bye! See you in the next video. Toodaloo! Doo-doo-doo-doo-doo! Doo-doo-doo-doo.